Here's another example of that happening. So Connor downloaded 2 orders of games and songs. 2 separate orders. He got some games and he got some songs in 2 separate orders. And he did it legally.
Really?
Yes. Those of you who pirate music and movies, shame on you. I know I'm not popular in that idea, but anyways, Connor ordered downloaded 2 orders of games and songs. The first order, he got 5 games, 4 songs for a total, there's a hint, of $26. The second order consisted of 3 games, 2 songs for $15. Okay, another total. All games cost the same amount, all songs cost the same amount, even though that's not always realistically true, but in this case it is. Write a system of linear equations. Wow. Write a system of linear equations and then determine the cost of one song and the cost of one game. Okay? So I'm going to let G represents the cost of a game, and even though I don't like using it, I hate using S.
Why?
Because it looks like 5. Whatever. Cost of song.
Use M for music.
Sure, M for music. I like that.
Now it looks like slow.
Alright. So, can you make a system for me? Can you create one equation that models the first order?
No.
Yep.
What would it be, Darren?
5G plus 4M equals 26.
5G plus 4M equals 26. Okay. The other equation, can someone else make it?
Don't everyone jump at once.
Yeah, right? This is all general form because you're dealing with totals. Good. Using elimination now. Again, I need to add or subtract to get rid of one of my variables. And in this particular problem, it may be unclear whether you should add or subtract. If you're not sure, sometimes it's good to just try it out. So let's add, just really quick. Don't write this down. Just watch. So if I add, I get 5G plus 3G is 8G, okay. 4M plus 2M is 6M, and then 26 and 15 is 41? 2, 1, 4, 2, 8? I think it's 1.
Is it?
Okay, so at this point, you should see a problem. Do you see a problem?
Yep.
What were we supposed to do?
Eliminate.
We were supposed to eliminate something. Did something get eliminated?
No.
No. If I had subtracted, would I be able to eliminate anything?
No.
No, because if I subtracted, I would have gotten 2G here, 2M, and 11. So what do I need to do, maybe before I add or subtract, to ensure that my addition or subtraction will actually eliminate something? Can you see a potential solution to solving that? Domino.
You could multiply the second one.
Exactly. In order for elimination to work successfully, the coefficients of whatever variable you want to eliminate have to match. Okay? So Domino's saying, all right, we want to eliminate M. To do that, we need to make sure that the coefficients match. Right now it's just 4 and 2. And she said, all right, to make sure they match, if I doubled this, that would be 4M, and then I could eliminate it. Now, when you multiply anything, or one side of an equation by something, you have to do that to both sides, right? Whatever you do to one side, you have to do to the other. And you have to do that to every single term. So if I'm going to multiply this by 2, that means everything else has to get multiplied by 2. Okay, so we just double all of this. And that will give, the top guy doesn't change. But the bottom one becomes 6G plus 4M equals 30. Okay, you haven't changed the values of G and M. Still the same values, just the appearance of the equation has changed. Now the question is, do you add or subtract that bottom equation to eliminate M? Subtract. Right? There's a saying that I use to help me remember. Same subtract. Because sometimes you're not sure if you should add or subtract. Same subtract means if the signs are the same, like positive and positive, if you subtract, then it will get eliminated, right? They both start with S, same subtract. That's how I remember. If they're both negative, also subtract. If one's positive and one's negative, then add. Okay? So same subtract helps me to remember what to do. So let's subtract. So 5g minus 6g is negative g. 4m minus 4m. 0. That's a good sign because we've eliminated something. That's what we were supposed to do, right? Equals how much? Negative 4. Okay? Making that 0 disappear because it doesn't really matter anymore. And dividing by negative 1, we get g equal to 4. So the number of games he ordered are... Sorry, not the number of games. The cost of one game. That's what g is $4. Pretty cheap. Okay? Now to find m. And again, you can use any equation. You could use this equation. You could use this equation. You can even use the equation that you doubled. But it would just be a little more work. So I'm going to use this top equation here to find m. Okay? So I put in my value of g. I'll leave it big here like this. So 5 times 4 plus 4m equals 26. And that's just 20 plus 4m equals 26. And bring over that 20. Crash through the algebra. Divide by 4, divide by 4. Sorry, show my work here. 3 over 2, that reduces to. Anyways, which is $1.50. Oh man, that's what I was confused about. So the songs are $1.50 each. Games are $4 each. These are both dollar values. There we go. Okay.